Okay, our objective today is to finish up exponents, and then we're going to practice simplifying all types of radical expressions, which is not new, but some of you may forget parts of it. So we'll spend about 20 minutes talking about that, and then you'll practice them in class for the rest of time. As long as you finish that, there will not be homework. All right, Jake, first warm up. What do you do first? Good. First thing is distribute the 4 to every single term inside parentheses. So in other words, step 1 is get rid of those parentheses. So we have a to the negative 12th over 3 to the 4th b to the 4th. John, what do we do next? Good. Put a to the negative 12th in the denominator. Flip it. What are we left with on top? Move that to the bottom. Maggie, what are we left with on top? Good. So we have 1 over 3 to the 4th, b to the 4th, a to the 12th. That's our answer. Good job. What did you have on top? Okay, you have to, because if not, then it's not going to be on the bottom. So you have to have 1 over everything. Anyone else have questions on number 1? We're only doing these 2 exponent problems. Leslie, okay? I didn't know if that was your hand or playing with your hair. Okay, number 2, Reno, what's the first step? Good job. And what are we distributing the 4 to? To what? You're right, but to what exponents? Like, good job. Be careful. The 4 only goes to the 2 and the d, because that's all the parentheses are around. So rewrite the first expression, which is 3 over 4d, times, this becomes 2 to the 4th, d to the 4th, over c to the 3rd. And at that point, you can just mush everything together, because it's really all one term. All right, Haley L., what's the next step? Don't know. Garrett, what do you think the next step is from here? Which 2? Good job. Divide same base. I'm going to circle them. The letter D here. If you're dividing same base, what do you do with exponents? Subtract. So we subtract them. We get 3 times 2 to the 4th, d to the 3rd, all over 4c cubed. Jackie, are we done? What did you say? That's it. We're done. Just making sure. We're done. There's nothing else you can simplify. That is your answer. The order you have them written doesn't matter. What is important is whether they're in the numerator or the denominator. So quick summary. When you multiply same base, what do you do with exponents? Add. Divide same base. What do you do with exponents? Good. Anything to the 0 power is good. Negative exponents, flip them. Make them positive. Power to a power, multiply. Okay, any questions on exponents? All right. On your blank piece of paper, I want you to put the top simplifying radicals or radical expressions. So put a title, radical expressions or simplifying radicals. I'll write it above here. So I am going to start with the very, very most basic radical problems. We're going to spend about 15 minutes on this. The first thing you need to remember is what a perfect square is. Can you guys give me an example of a perfect square? Hopefully you remember these. Will, what's a perfect square? Say that again. 3 squared, you said? 2 squared? 2 squared is 4, so square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. We had a list way at the beginning of the year of perfect squares. As long as you know what a perfect square is, these are not difficult. So let's put number 1. Here's our first practice problem. And let's start with the square root of 32. So number 1, we're going to start with the square root of 32. So the point of this is you need to keep your answer exact. Do not change this to a decimal. We need to ask ourselves, what is a perfect square that goes into 32, or what is the largest perfect square that goes into 32? Heather? Good. 8 and 4 work, but that's actually not the largest perfect square. It works, and you can still do it that way, it just takes longer. Anyone know what there's a larger perfect square that goes into 32? Jake? Good. So here's what I would do. I would change it to be square root of 16 times square root of 2. You can still do this problem with 8 times 4. As Heather said, it's not wrong. It just will take 2 extra steps. So you can do it that way if you want, Heather. At this point, we know 16 is perfect. So I want you to circle it. 16 is a perfect square. We're going to take the square root of it, which is 4. You're going to keep it in front. Leave your square root of 2 there. There's nothing you can do to simplify that square root of 2 further. So that's the answer. 4 times the square root of 2 is the exact same answer as square root of 32. This is just simplified completely. Do you guys remember this? Some of you? Some of you are just sitting there. Give me a head nod this way or this way. Do you remember this? All right, number 2. Let's do square root of 24x to the 4th. Square root of 24x to the 4th. I'm going to keep them easy for now. Okay, so first step on this one is separate them. So let's separate them to be square root of 24, square root of x to the 4th. So now, what can we change 24 to? So something times something is 24, but one of them is a perfect square. I should have more than just Jake. You guys know how to multiply. What times what is 24? One of them is a perfect square. Sam? Good. So 6 times 4, square root of x to the 4th. I'm just going to rewrite. All right. What can we circle because we know it's a perfect square? Well, what can we circle? And? Nope, 6 is not a perfect square. Yeah. Anyone remember the rule with variables? How do you know if a variable is a perfect square? How do we know? Will, you remember? Good. If it has an even exponent, a variable is a perfect square. How do you take the square root of something like x to the 4th? What do you do to the exponent? You divide it by something. 2. Thank you, Zach. So anytime a variable has an even numbered exponent, divide it by 2. So the square root of 4 is 2. Square root of x to the 4th is x to the 2nd. Leave square root of 6 next to that. So your answer to this one is 2x squared, square root of 6. Easy? Questions on that one? Okay, number 3. Let's do square root of 36x squared. Square root of 36x squared. And your quiz next week on this on Tuesday will be very similar to these problems. It's not going to get much more difficult. Okay, first thing you always need to do is separate it. So square root of 36 times square root of x squared. Amy, which ones are we circling? So which ones are perfect squares? 36 too. So both of them, they're both perfect squares. Haley L, what's the square root of 36? Good. 6. Dirk, what's the square root of x squared? Say that again. Square root of x squared. Not 1. Something's 1, but not the whole thing. Good. x1. So the square root of x squared, I think that's what you meant, is x to the first power, but make sure you leave it as x. You can put the 1 there if you want, but you don't have to. So the answer to that one is 6x. All right, let's make them a little harder here. Okay, number 4. Let's do square root of 150, x to the 7th, y to the 3rd. Okay, so I want you to take a second. See if you can find a perfect square or the largest perfect square that goes into 150. That's an x to the 7th and y to the 3rd. Is that what you're asking, Jake? Yeah. So see if you can find a perfect square or the largest perfect square that goes into 150, if you don't already know. While you're looking for that, the first thing that we do need to do is separate all of them to be in 3 different radicals. Think of money. Think of this as being like $1.50. That might help you. Think about a perfect square, the largest perfect square that goes into that. Okay, we have one hand. When you think you know, put your hand up. Oh, go ahead, Will. Sorry. We're going to split them. Yep. John, think you know? And? How many quarters are in $1.50? Good job. So we're going to change this to be 25 times 6. 25 times 6 is 150. 25 is a perfect square, and there are not any other perfect squares that go into 6. What can we change x to the 7th to? We haven't done this yet. Well, you can, but that's not going to save you some time. Zach? Yeah, x to the 6th and x, well, if you take, and for anyone else, take the largest even number that's in that exponent. For example, yes, x to the 7th is odd. If you could just go down 1 to 6, it's even. So you're only left with the x. This one, of course, is going to stay in the radical. So it's kind of like finding the largest perfect square. Okay. Y to the 3rd, you can change to y to the 2nd and y. If I go too fast or too slow, please tell me, guys. All right, Haley Waters, what can we circle because it's perfect? And? Which other exponent is even? Good. So remember, guys, any variable that has an even exponent, it's perfect, so circle it. Okay, bless you. So let's take the square root. Square root of 25 is 5. Square root of x to the 6th is x to the 3rd. Divided by 2. Square root of y to the 2nd is y. What are we left inside the radical with? Zach, go ahead. Good. We are left with 6xy because there are not any perfect squares that go into that. Who was that? Did you guys see someone knock on the door? Did you hear someone knock on the door, or am I going crazy? All right. You really didn't see anyone walking by just messing with me? Okay. Any questions on that? Jake, your lookout. Okay. Okay. All right. It was probably Trevor or Kyle, if I had to guess. I don't know. All right. Yeah, probably. Okay, number 5. Let's do 2 more, and I think you guys should be okay. All right, let's do something a little different. 2 times the square root of 1,000 x to the 8th. So keep a 2 in front this time. All right, so 1,000. What is a perfect square or the largest perfect square that goes into 1,000? Well, yep, 100. So the 2 in front, just leave there. That 2 will end up multiplying with the perfect square. So 1,000 is 100 times 10. The largest perfect square that goes into 1,000 is 100. And then the square root of x to the 8th, you don't need to split up because it's an even exponent. So leave that where it is. Okay, Sage, what can we circle? Good. Good. So here are 2 perfect squares that we can circle. Now be careful. The square root of 100 is 10. So 2 times 10, I'm going to leave that in front. Amanda, what's the square root of x to the 8th? Good. So leave that in front. The square root of 10, leave inside the radical because it's not a perfect square. So leave that inside the radical. What's the answer? Mush it all together. What's the answer, Will? Good. 20x to the 4th, square root of 10. Questions on that one? All right, one more. Number 6. Negative square root of 324. So 324 x squared all over 25. Anyone remember how to do these? It's the last one, a little different. So it's a fraction. How do we split these ones up? Zach, do you remember how to split them up? Good job. So split them up from numerator and denominator. What's going on with that negative in front? Just leave that negative there. Once we take square roots, that negative is just going to stay there, just in the front of everything. That just means the entire problem is negative. You don't need to distribute that. Okay? Are any of these perfect squares? Well, any of them perfect squares? Yep. Anything else a perfect square? Sage? Good. Anything else a perfect square? Yep. So when we split all these up, they are all perfect squares. So I'm going to circle all of them. You don't have to do this step. But if I split them up, all of these are perfect squares. So all you're doing is taking the square root of every term in this problem. We get negative 18x, because the square root of 324 is 18. Square root of 25 is 5. That's it. So do you think you can do these on your own? Okay. Any questions? All right, you can leave your notes out if you want. I am going to give you a worksheet. It's not very long. This packet is stapled, but we're not, there's only 2 pages. We're not doing all these, so no book today. Is that enough, or is that? Is that you? Jake, was that you the first time? Oh, gosh. You know, and you want to have your own seat. You don't want to have homework. Ah, jeez. All right, put your name on this and flip to the second page, please. You leaving early, Sage? You have a doctor's appointment, right? I figured that. Yeah, I know you're not feeling well. All right, turn to page 2, please. So, simplifying radicals worksheet. All I want you to do is page 2. There's only 16 problems here. These are very similar to the problems that we did. Of course, besides the ones with fractions, we'll do more of those on Monday. Yeah, you can do it on here. Yeah, this is yours. I already had copies made from this. So yeah, you can do it on the worksheet. If you need paper, there's some back there. Help yourself. But just page 2. You guys have about 16 minutes. Remember, split it up. Find the largest perfect square that goes into it. If it's a perfect square, just take the square root of it. If there's variables, make sure you split them up to be an even number and then an odd number, which will just be 1, to take the square root of an exponent that's even divided by 2. Okay, if you need help, let me know. I'll be around. Make sure this is done for Monday. Yeah.